Okay, so part C. You have to wonder whether the examiner was sitting in his apartment building and he did drop the phone while he was trying to think of scholarship questions. Ben is on the top floor of an apartment building and has a phone that emits a single ringing tone at 440 hertz. While picking up the ringing phone, Ben drops it so that it falls off the edge of a 0.7 metres high top floor ledge he is leaning on. Sometime later, Ben hears a reduced frequency of 416.2 hertz. The height of each floor is 3.1 metres. Calculate the number of floors the phone must have fallen when it emits the wave that Ben hears. State your assumptions. Right. Good idea. Just sketch out the diagram, what you've got here. Say you've got Ben, it's on an apartment building. So here's his phone. He drops it and it falls off the edge of a 0.7 metre high ledge. So we've got 0.7 metres. One assumes then that's the floor. Then we've got a number of floors of 3.10 metres. So, drop the phone. The phone is obviously going to gain velocity as it falls. Therefore, the frequency that Ben hears is going to change as the phone falls. And because it's falling going away from Ben, this time the Doppler effect will cause a lower frequency. So that frequency will drop, which corresponds to what we've got in the question. So 440 hertz is what we had. It goes to 416.2 hertz. Okay, so there's our change in frequency. Calculate the number of floors. Okay, so if we had a change in frequency, therefore we can work out the velocity. If we know the velocity is just in free fall, just our objects in free fall calculations will therefore tell us the distance it must have fallen. It's a nice way of filling the two in one question. Now, our Doppler effect formula. Hopefully it's on our list of formulae. The Doppler effect, there we go. F prime equals F VW over VW plus or minus V source. So velocity of the wave over the velocity of the wave plus or minus the velocity of source, depending on whether it's going towards us or away from us. So this is the heard frequency. This is the frequency when Vs equals 0. Okay, so what do we want? We want to know Vs. Is it plus or is it minus? Well, in this case, the frequency is going to decrease. Therefore, we're going to want a plus there to bring that down. So, F prime equals F VW over VW plus Vs. So that implies, so if we want to find Vs, 1 over F prime equals VW plus Vs over F VW. So that's equal to 1 over F VW over VW is 1 plus Vs over VW. Therefore, 1 over F prime, take 1 over F, getting rid of that bit, equals 1 over over F, Vs, and then VW. Try to find Vs. So multiply by F, multiply by VW. So F over F prime, take 1, all times VW equals Vs. So here's our Doppler effect. So what we know our frequency, so that's 440 Hertz. We know our F prime, 4 on 6.2. Take 1 times the velocity of the wave, and we hope they give the speed of sound. So they give the speed of sound.
Yeah, it's given us 340 meters.
340 meters per second equals our velocity. So that is d bigger than 1. So we're going to get a positive velocity out. And again, we need a calculator, equals 19.44. 19.4 meters per second. That is our velocity of the falling foam. How far has it fallen? So it falls from rest. So what we want to do is our kinematics formula that relates our final velocity and our initial velocity. We know that acceleration and distance. So we don't want time in there. So again, I'll just check the way we put it in this one. Maybe it's not even in here.
I think we use V subscript
Vector to know it.
rather than
Right.
UNV.
So V final squared minus V initial squared equals 2 times your acceleration times your distance. Initial is 0, acceleration is 9.81 meters per second squared. We want to know distance, so our distance equals V final squared over 2 times our acceleration, which is equal to 19.4 meters per second squared over 2 times 9.81 meters per second squared equals 19.4 squared over 2 divided by 9.81 equals 19.18. 19.2 meters. Now hopefully that is a whole number of floors plus the 0.7. So if we take 0.7 off 19.2, we get 18.5 meters. Is that a whole multiple of 3.1? It is, it's 6. So that equals 6 times a floor height.
There may be a rounding
So,
thing in there to bring it up to 18.6.
Thing there, yeah. Okay, what were our assumptions? I guess we're assuming it falls from rest. We're assuming that the phone is a point source, it's not something that large. You can probably think of a whole lot more. No air resistance,
Yeah.
Any more?
I think that
It's probably
hasn't
the
had
key
anything on the way down.
assumptions. Yeah. Okay.
Yeah.